Hello there, welcome to this video. So here we're going to learn how to multiply matrices. So just before we start, we need to set some records straight. First off, you need to know that a matrix cannot actually be multiplied with another if the number of elements within the row of that matrix is not equal to the number of elements that there are in the column. So let us say the matrix A, right, which is 2, 1, and 4, and we have 1, 0, and 3. And let us use another matrix. Let's say the matrix B, which is 1, 0, 2, and 6. Now we have two elements within the first row and virtually all the rows within the matrix A. But we have 4 elements within the row of the second matrix. This is matrix B. Now within each column of the matrix B, there is just one element, so that cannot actually work. So there is 2 elements within the first row of the first matrix, but just one element within the second matrix, within the first column of the second matrix. So this would not actually work. But if we were able to have another row such as this would actually work because you would have 2, 1, and 1 with any other element that there might have been there. So that is what you need to know for 1. So let us look for the matrix that the matrix A can multiply with from face value. So we have a matrix such as E. So the matrix E can actually work. So this is going to be 1. You got 2 there. This is 1, -1. This is 0, and this is going to be 7. Now this would actually work because we have 2, 1, and 1, 2. We have a 1, 0, and 1, -1. We have 4, 3, and 0, 7. That doesn't mean that you just work it exactly as I circled them. There is actually some intricacies involved, so we're actually going to take it a little bit gradually. But I'm just trying to tell you that you have 2 elements within each row of the matrix A, and then you also have 2 elements within each column of the matrix E, which works. Okay? Now the second thing you need to know for multiplication of matrices, if you have the matrix form of the first matrix, let's say this matrix A, which is a 3 by 2 matrix. Basically, this is a 3 by 2, and then this is a 2 by 3 matrix. The result of the multiplication should be the combination of the first number with the last number of the forms of the 2 matrices. So the result should be a 3 by 3 matrix. If you do not find this answer, then you are actually wrong. So you just need to bear that at the back of your mind. So let's try to work it. Now let's say you are asked to find the value of f multiplied by g. What is going to be the answer to that? If you feel you can actually do it yourself, feel free. You can pause the video and do that. So let us go ahead and find what the answer will be. So the matrix F, we have 1, this is going to be 2, this is 1, 0, 1, -1, and this is 6, 2, and 1. And the matrix G, we have -2, this is 0, and we have 8, this is going to be 6, this is -4, this is a -2, and this is 2, this is 6, and we have 0 there. Now, we take the first element or the first row with its elements and multiply with the first column, and multiply with the second, and finally with the third. Now, all the answers that we would have will form the first row of the resultant matrix. So let us take it more gradually. Now, this is what we need to do. This is the first row, right? Now, we have the first element within the first row, which is 1. we're going to use 1 and multiply it with negative 2. So that basically gives us negative 2. Now, we need to use this whole row and multiply it with the first column for the first step, right? So we have 1 multiplied by negative 2, which of course gave us negative 2. And we're going to have 0 multiplied by 0. But because we have the first column in the second matrix be multiplied with the first row, this is how the answer will be placed in the resultant matrix. You will have the answer for the first row and the first column being within this place. And the answer for the first row and the second column being here, and the answer of the first row multiplied by the second, or rather the third column being here. So let us go back and take it in order. So this is 0 multiplied by 0. That is going to give us a 0. So how can we do this? Should we write a 0 here or what? So what we need to do, we need to add it. So this is going to be 0. Then we have 6 multiplied by 8, which gives us 48. So I'm just going to write that there. Then the next thing, we need to use this row and multiply it with the second column. Now, if I did that, the answers will be within this place. And then finally, I will use the first row and multiply it with the third column. So that is going to leave or create the last row for the resultant matrix. Or I should rather say the last column. So let us go gradually. I'm going to wipe this out, clean this out. So we have 1 multiplied by 6, and that is going to give us a 6. So we would add that with 0 multiplied by negative 4, which is going to be a 0. And we have 6 multiplied by negative 2, which should give us a negative 12. And so even if we added that, it should still change to a negative 12. Now we need to take the same row and multiply with the third column. So that should be 1 multiplied by 2. So that is going to give us 2. Then we have 0 multiplied by 6, which gives us 0 basically. Then you have 6 multiplied by 0 also. So that is going to give you a 0. So that is what we have. Now you need to add all these values to find each element which will be in each row or column, as the case might be. So we are basically done with the first row of the matrix. Now we need to go to the second row of the first matrix, which is 2, 1, 2. Now I'm going to take 2 and 1 and 2 and multiply with the first, second, and the third column of the second matrix. So this should be 2 multiplied by negative 2. So what should that give us? That basically will give us negative 4. So I have 1 multiplied by 0, which is going to give us a 0. And then we have 2 multiplied by 8. So that should give us 16. Now we're going to take the same second row and multiply with the second column. So the answers should be here. Now we have 2 multiplied by 6. So that gives us 12. And this is going to be 1 multiplied by negative 4. So that should basically give us negative 4. We need to have a negative here. So this should be negative 4. And then we're going to have 2 multiplied by 6. So that gives us a 12. So that should be plus 12. Now we have the last column. So this is going to be 2 multiplied by 2, which gives us a 4. And then we have 1 multiplied by 6. So that should be 6. And lastly, we have 2 multiplied by 0. So that basically will give us a 0. So this is plus 0. Now we need to work with the last row of the first matrix. So this is going to be 1 multiplied by negative 2. So that is going to be negative 2. And then we have plus negative 1 multiplied by 0, which would give us a 0 basically. And then we have 1 multiplied by 8, so that gives us positive 8. Now we go to the second column, which is going to be 6 minus 4 and minus 2. So this is 1 multiplied by positive 6. That is going to give us a positive 6. And then we have negative 1 multiplied by negative 4, which gives us a positive. So this is going to be plus 4. Now we have 1 multiplied by negative 2. That should give us a negative 2. So I need to write a negative 2 there. Now we have the last column. This is the last column for the stuff. So this will be 1 multiplied by 2. That will be 2. Then we have negative 1 multiplied by 6. That should give us a negative 6. So I'd write that there. And we have 1 multiplied by 0, which basically gives us a 0. So this is how to work it. And the final, or I should rather say, well, that should actually be the last step actually. But if you're done with that, you need to find out what the form of the matrix is going to be. So let me wipe this out. So we have negative 2 plus 0 plus 48, which basically forms 48 minus 2, which should give us a 46. Then here we have negative 4 plus 16. So that should give us 12. And then here we have negative 2 plus 8. So that gives us a 6. And we have the second column where we have a 6 minus 12. So that should give us a negative 6. And here we have 12 minus 4, which is, that is 8. Now 8 plus 12 would give us 20. So that is going to be a 20. Then we have 6 plus 4 minus 8. So that should give us 8. Well, this should be a 6 plus 4 minus 2. Now we have 2 plus 0, which is 2. And here we have 10. And here we are going to have a negative 4. So this basically will be the answer to the question, matrix F multiplied by matrix G. Let's see the answer for another one. Now, if you are able to tell the answers to this, then you should be very good in finding the answers to multiplication of matrices. How about this one? The transpose of the matrix A multiplied by the matrix B. Whoa, the matrix C rather. So this is the matrix A, and we need to transpose it. So basically that is going to be 2, 1, and we have 1, 0, and we're going to have 4 and 3 here. So this is A transpose, and we need to multiply this with C. So C, need to redraw this. This is going to be 1, negative 1. You have 0 here, and this is a 0, 4, and we got a 5 there. So as you can see, we have 3 elements within the row of the first matrix and 3 elements within the column of the second matrix, which is actually the principle that is required. So this will work. Now, what is going to be the form of the matrix that will be resultant from this operation? So we have this matrix to be a 2 by 3 matrix, and this is a 3 by 2 matrix. So basically the answer to the matrix that we should form is a 2 by 2 matrix. If you do not form this, the answer is actually going to be wrong. So let's see how that can be done. Okay. So we're going to use this part. Now we have 2 multiplied by 1. If you multiply 2 by 1, that should give you a 2. Now we're going to add that to the multiplication of 1 by negative 1, which is basically going to give us a negative 1. So I need to change this stuff. That is negative 1. And then we have 4 multiplied by 0, which is going to give us a 0. Now next up, we need to use this same rule and multiply with the second column. So the answer should be around this place. So this is going to be 2 multiplied by 0, which should give us 0. and there is a 1 multiplied by 4, which gives us 4. And lastly, we have 4 multiplied by 5, which basically gives us 20. Now we have the last row for the first matrix, multiplying by everything within the second matrix. So this is 1 multiplied by 1, and so that should give us 1. And we need to add it to the multiplication of every other thing within this row and the first column. So this is going to be 0 multiplied by -1, so that should be 0. Now we have 3 multiplied by 0, so that should still give us a 0. Now we have 1 multiplied by 0, which is going to give us a 0. And there is 0 multiplied by 4, which is still 0. And finally, we have 3 multiplied by 5. So that should be 15. So this is going to be 2 minus 1, which gives us a 1. And here we have 1 plus 0 plus 0, which still gives us a 1. And here we have 20 plus 4, which is going to give us 24. And lastly, we have 15 there. So that is basically the answer to this matrix. And as you can see here, this is a 2 by 2 matrix. So we are really on track. This is the answer to the question. Try this one. So here we need to multiply the matrix E with the matrix F and find the transpose of the answer. So how are you going to do this? Feel free to pause the video and try solving it by yourself. So this actually comes off easy, but first off, you need to check the solvableness or solvability. If there is actually a word like that, just try to find out whether or not this operation can actually be carried out. So we need to find out the number of elements which are in the first matrix and the number of elements which are in the second matrix, within the column of the second matrix. So within the row of this first, we have 3 elements. And for the second matrix, we also have 3 elements within the column. So basically, this is going to work. So this is 1, and this is 2. This is 1, this is -1, this is 0, and this is 7. So we need to multiply it by this matrix. I think I need to reduce that. So this is 1, we got 2, 1, and this is 0, 1, -1. This is 6, got 2, and 1 there. So let's see what that's going to give. So we need to take this, multiply by this, this, and this. And the answers, of course, will be within the first row. But what is going to be the result of this operation? Now we have this matrix to be a 2 by 3 matrix. And this one, this is a 3 by 3 matrix. So basically the form of matrix that you should find should be a 2 by 3 matrix. So bear that at the back of your mind. Now, 1 multiplied by 1 will give us 1. So I need to add that. 1 multiplied by 2, that is going to give us a 2. And 0 multiplied by 1, that is going to give us a 0. Then we're going to use the first row and multiply it with the second column. So this is 1 multiplied by 0, which basically forms a 0. And we have 1 multiplied by 1, which should give us a 1. And then we have 0 multiplied by -1, which basically gives a 0. And finally, we use the last column for the first row. So this is 1 multiplied by 6. That is going to give us 6. Plus, we have 1 multiplied by 2. So that is going to give us a 2. Lastly, we have 0 multiplied by 1. So that gives a 0. Now we have this last row with everything within the second matrix. So this is 2 multiplied by 1. That gives us 2. And here we have negative 1 multiplied by 2, which is going to give us negative 2. And we also have 7 multiplied by 1, which gives us positive 7. Now we have 2 multiplied by 0, which is going to give us a 0. Then we have negative 1 multiplied by 1, which should give us a negative 1. And there is 7 multiplied by negative 1. So that should give us a negative 7. Then we have 2 multiplied by 6, so that is 12. And negative 1 multiplied by 2, that is a negative 2. And 7 multiplied by 1, that gives us 7. So this is 1 plus 2 plus 0, so that is 3. And we have 2 minus 2, which is 0, and plus 7, we're going to have 7 there. And here we have 0 plus 1 plus 0, so that should give us 1. And here we have negative 1, negative 7, so that should give us a negative 8. And for the last column, we have 6 plus 2 plus 0. That gives us a positive 8. And here we have 12 minus 2, which gives us 10. And 10 plus 7, that should give us 17. Well, I need to rewrite that. So this is what you have. This is going to be the answer to the question. Now, try this one. So if you were given this question to solve, what is the best way to go about it? Now, the best thing I need to do is to take the power, or I should rather say the superscript of t, and distribute it to each matrix form. So this is going to be ct of t multiplied by a of t, and that is going to be multiplied by e t of t. Now if you have the transpose of a transpose, that basically gets eliminated and you would have the original matrix reforming. So this is actually the matrix C. And here we have the matrix A, and finally we have the matrix E. So this is basically what you need to find. C multiplied by the matrix A, the transpose of the matrix A rather, and multiplied by the matrix E. So that is basically what we're going to do. So let me rewrite that. So this is going to be C multiplied by A transpose multiplied by E. So let us start with the first. That is going to be C multiplied by A. So what is the matrix C? We have 1, minus 1, and 0. This is 0. We have 4, and this is 5. And then we have A transpose. So A transpose, that is going to be 2, 1. And we have 1, 0. This is going to be 4, 3. So of course this can actually work. Now here we have a 3 by 2, and here we have a 2 by 3. So the answer obviously should be a 3 by 3 matrix. That is what we're looking for. And if we are able to find that, we're going to use it and find the answer to the multiplication with E. Now, if that is going to be a 3 by 3 matrix, the first thing you need to ask yourself is it going to work? Because what we have here is just E. Okay? So if that was actually an E transpose, that should actually have worked. So that basically will be what we'll do. Now we need to multiply C by A transpose. So this is going to be 1 multiplied by 2, which is going to give us 2. That will be plus 0 multiplied by 1. So that is 0. Then we have 1 multiplied by 1, which is 1, plus 0 multiplied by 1, which is going to be, well, that is 0 multiplied by 0. So that is 0. We have 1 multiplied by 4, which is 4, and 0 multiplied by 3, which is 0. Second row, we have negative 1 multiplied by 2, which is going to give us a negative 2. And we have 4 multiplied by 1, which gives us a 4. Then we have negative 1 multiplied by 1, which is going to give us a negative 1. And we have 4 multiplied by 0, which is basically 0. And we have negative 1 multiplied by 4, which is negative 4. And 4 multiplied by 3. So that will give us 12. Last row, we have 0 and 5. Now 0 multiplied by 5. Well, 0 multiplied by 2 rather. That should give us a 0. Then we have 5 multiplied by 1, which is a 5. And then we have 0 by 1, which is a 0. And 5 by 0. So basically this is 0 plus 0. Then this is 0 multiplied by 4. So that gives us 0. And 5 multiplied by 3. So that is going to give us a 15. Well, I need to rewrite this. So this is going to be 2. And here we have negative 2 plus 4, which still gives us a 2. And here we have 0 plus 5. So that is going to be 5. Then we have 1 plus 0. So this is 1. Then we have negative 1 plus 4. That is negative 1. Then we have 0 plus 0. That is 0. And here we have 4. And here we have negative 4 plus 12. That is going to be 12 minus 4. So that basically should give us 8. Then we have 0 plus 15, which is basically 15. So this is the 3 by 3 matrix that we have. Now we need to multiply this with E transpose. So let us rewrite this. I need to wipe this stuff out. So this is 2, 1, 4. You have 2, negative 1, 8. And this is 5. This is 0, 1, and you have 5. Now, remember, we actually didn't have a transpose for the matrix E. Initially, we had a transpose, but that was actually in a bracket which carried a transpose, and that actually left. Now, in this case, I am just trying to work it in a case where you are actually given something like this. So if you are given something like this, then you need to solve it further. So that is exactly what we're trying to do now. So I need to multiply this by E transpose. Now this is E. So if I wanted to transpose this, this is going to be 1, 1, 0. And we would have 2, negative 1, and 7. So this would go with this, and basically that will work. Now this is a 3 by 3 matrix, but this is a 3 by 2 matrix. So obviously what we should find should be a 3 by 2 matrix from the combination formula that I taught you. So let's try to solve it. Now we have 2 multiplied by 1, which is going to give us 2. Then we have 1 multiplied by 1. So that is going to give us 1. Then we have 4 multiplied by 0, which is going to give us 0. And we have 2, 1, 4 multiplying by 2, negative 1, and 7. So that should give us a 4, negative 1, and plus 28. Now, we have 2, minus 1, and 8 multiplying by this and by this. So this is 2 multiplied by 1, which gives us 2, and negative 1 multiplied by 1. That is going to give us negative 1. Then we have 8 multiplied by 0. So that is going to give us a 0. Now we have 2, 1, 8 again, multiplying by this one. So this is going to be 4. And we have negative 1 multiplied by negative 1. That is going to give us a positive 1. And finally, we have 8 multiplied by 7. So that is going to give us 56. And we have this last stuff multiplying by everything. So here we have 5, 0, and 15. Now 5 multiplied by 1 gives us 5. 5, well, that should be a 0. 0 multiplied by 1, that should give us a 0. And here we have 15 multiplied by 0. which still forms 0. And for the last column, we have 5 multiplied by 2, so that gives us a 10. And we have 0 multiplied by -1, so that gives us a 0. And finally, we have a that should be 15. 15 multiplied by 7. So what is that basically going to give us? So that basically should give us 105. Okay. Now 2 plus 1 plus 0, that is a 3. 2 minus 1, that is going to give us 1. And we have 5 plus 0 plus 0, which is basically 5. Now here we have 4 minus 1 plus 28. 4 minus 1, that gives us a 3. Now 3 plus 28 should give us 31. Now here we have 4 plus 1, which is 5, and plus 56. So that should give us 61. And lastly, we have 10 plus 0, which is 10, and 10 plus 105, that gives us 115. So this is the answer to that question. C, A transpose multiplied by E transpose. If you didn't have a transpose here, this wouldn't actually have worked. So the answer should just have been stuck at C multiplied by A transpose, because E is not actually in the form in which the result from C multiplied by A transpose could work with. So in order just to show you an example, that is the reason why I changed it to E transpose. So the answer for this complete form is this, which as we said should be a 3 by 2 matrix. So that is going to be the answer to the question.